Okay, so I'm just going through the MYP3 Unit 3 Second Chance Test, Pythagoras. We've got to find the missing sides in all of these triangles, or both of these triangles in the first two questions, and we've got to construct the triangles accurately for question 4. So I'm going to kind of do all of that in one go. Now this first one here, we've got 7 as the base, we've got 4 up here, and then we've got some unknown thing here, and we don't yet know exactly how long that is or where it goes. So before we've worked everything out, it might be an idea to turn the page around and then draw 4 as the base, and then the P, we don't know how long it is, but we know it goes straight up because it's a right angle there, so it's 90 degrees to the base, and then we can construct the 7 with a compass, or a pair of compasses I should say. So I'm just going to do that. So I'm just going to leave myself plenty of space for this P here. I know it's not going to be any more than the 7 centimeters, so on my page here I'll leave myself about 7 centimeter space, and then I'll draw the 4 centimeters just down around here somewhere. So 1, 2, 3, 4. Actually using the squares in my book there because they're half centimeters each, so that's 4 centimeters. So this side P, we know it's going to go straight up there, but we don't know how far. And then we know that there's a side from the other end here that's going to be 7 centimeters, but we don't exactly know where to put it. So what we're going to do is get our compasses to 7 centimeters like that. So that's 7 centimeters now. I'm going to stick the pin in the one end, and then with the pencil I'm going to draw an arc there. You can just about see that. And bearing in mind that we know that the side on the right here is going to go straight up, it's basically going to go straight up until it hits that arc, and then once it hits that arc, that makes the triangle. And then we know that that is indeed 7 centimeters from the end, because we had our compasses at 7 centimeters when we drew that line. That's 90 degrees in there, and then I'll just turn my question paper round again, and we've got to determine the value of, this is called P in here. Okay, so we can see that P is one of the shorter sides, because the 7 must be the longest side because it's opposite the 90 degree right angle. So I'm going to write P squared plus 4 squared is equal to 7 squared. That's basically Pythagoras. The 2 shorter ones squared equals the longer ones squared. And I've written it with the 2 on the left and the odd one on the right, so that I've got the P, the unknown thing, on the left. That's just going to be a little bit neater later on. So P squared plus 4 squared is 16, 4 times 4, and 7 squared is 49, 7 times 7. So P squared plus 16 equals 49. I'd quite like the bit with the P to be on its own, so I'm going to take away the 16, but because an equation is like a balance, we have to take away 16 from the other side as well. So P squared equals 33. I've taken away 16 from both sides. So if P squared is 33, then P must be the square root of 33, which is, well, 5 times 5 is 25, and 6 times 6 is 36. So it's going to be somewhere between 5 and 6. Let's just get my calculator on that, see if it will go into scientific mode. I think I have to unlock my phone first for it to do that, so let's just type in the secret thing there. And calculator on. Any minute now. Okay, so square root of 33. On this one you have to type 33 first and then square root, which is a bit annoying. 5.74 and a bit. I'm going to call that 5.74 centimeters to 2 decimal places. and just for good measure I'm going to underline that neatly.